Hello everyone. Good evening. Let's start today's session. Uh, I am Shivam Aggarwal, the TA for this course, which is entitled as Machine Learning and Artificial Intelligence in Materials Engineering, which is being instructed by the Professor Krishanu Vishwas, uh, MSc Department IIT Kanpur, on the NPTEL platform. And I am the PMRF TA for this course. Uh, I have given the eight live interactive session till, and today is our ninth live interactive session. In the previous session, we have discussed about the how the machine learning is going to is used in the material science field, and people have done with the deal it with the various kind of problem like classification problems as we talk about the like multi-component alloy or high entropy alloy, or we have also discussed about the some regression model which is the stack calculation of the prediction of the stacking fault energy. And when we talk about the like the image processing techniques, then we have discussed a paper which is worked on the image segmentation. So, and we have also discussed about the NLP problems, like how the NLP is going to be used in the material science, like how we give it to the data from the literature, and uh, it will and we get the structured from data from that unstructured data. So till now we have discussed about the all the kind of the things which can be useful, maybe which is a very common problems we have discussed. And besides this, you can create your problem and uh, solve by using the methods we have discussed. So now we are discussed from the last session like how the machine learning is used. So like in practical application, like how you can code for that, how can you load your data, how you can prepare your data, and how can you use the different methods of the machine learning of the Python code to got those results. So in the last session, we have discussed about the like how can we load the data in the Python notebook, especially in the Google Colab notebook. So continuing that session, I will try to discuss about the like the different math, different analysis of the math model, like how can you clean your data. Like as we discussed about the when we have a data, there is a as the data would be the like the DFT generated data or any by using any computational technique data, or you can also generate your data by experiments, or you can take the data from the literature. So these are the some methods by which you get your data. But in your data there would be some problem, like there would be some outliers. So how can you see your data from a data perspective, and how can you see like so there would be the some modification. So ultimately you have to clean your data, which would be the suitable for your machine learning model. So for that purpose, that task is called the data cleaning. So today we will discuss about the data cleaning, and then we will discuss about the different modes of the standardization or the normalization of the data, why that is needed to you to do that. Then we will try about the like how you can select your features. So all the things we will discuss in this session, that is on the data, which is just a dummy data that we have created on the Python itself. This is not a data, this is not actual data which we got from any computational or any literature. So please keep this thing in mind. This is not the original data. This is just a dummy data. So let's start. Okay. Okay. This is the thing which we have done in the last session. In the last session, we talk about the how you can generate a demo data. Like it's not just a demo data, you can also create your actual data inside. Like you have a data in the written form in so and you can type your data in the Python notebook. So you can generate your data by using this thing. First of all, you have to create a definition like the uh, first of all, you have to load the pandas and the numpy, which is widely used libraries for handling the data. So first of all, you have to create your data. Then first of all, you have to give the column name, like what's the type head of the column, like which property is showing that column. So first of all, you have to give that name. Then you have to enclose that in the inverted commas, and then there is a colon, and in the square bracket you have to put your values. So here the values are into the inverted commas. Why? Because this is a string form data. That's why it is enclosed into the inverted commas. If you not include the this string into the inverted commas, your model, your code is not getting this information. That will show an error. So for the string, you have to enclose that in the inverted commas. So then there is a thing which is the band gap title or band gap is the name of that column, which property that shows. And there is a colon, then in the square bracket, there is the numerical value. So there is it is a numerical value. So there is a no inverted commas. And beside this, there is here you saw this np.nan. What is this np.nan shows? This np.nan shows the not a number or not a value. Just it's just a like if I create a Excel sheet from this data, that is just an empty cell in that. So if I talk about that composition, so there is a no composition. It's just a empty cell at this position. It means fourth cell uh, fourth row in this column is empty. First row in this column is empty. Fifth row, sorry, fifth cell in this column, fifth cell in that fifth row in this column is empty. Okay, so that's the thing. Here you can see this is the NaN. This is just a in the Python. If any cell is empty, that is shows as a NaN. So that's why it is the NaN. It means this cell in the Excel notebook is just empty cell. Here you can also see this. Okay, first of all, I have to save this. This is our data. Here you can see this data, which is generated by us. So here you can see this is the title of the column, and this value is empty. This value is empty, and this cell is also empty, which is shown by the NaN in the Python model. So this is the same. And for the importing the data, you can see these, and we have used the different methods here. So let's start for the today's session. Uh, to create a demo data. So here we are going to create a demo data, and we will analyze those that data by using the different thing, and you can also look for your data by using these codes. Okay. So first of all, to create a demo data, first of all, we have to install the libraries like pandas and numpy, which are generally used for the data handling. Then, first of all, we have created a synthetic data which has some duplicate points and some NaN values, and I will show you how you can remove those things. So I created data from range 1 to 21. It means just 20 points. And the material name, these are the some composition name. This is the category of that data. Like here you can see some of the perovskite material, and some are just oxide materials like tin oxide, cobalt oxide, nickel oxide, and strontium titanate is a perovskite material. And then there is a band gap. I'm not going to use the actual band gap, so I just check the some value which is some random values between 1.5 to 3.5. Same as I just suppose like there is some processing parameters like by which this material is synthesized. So processing parameter one and processing parameter two, this can be some like annealing temperature, annealing time. So you can take those. So I choose these are also the some random values from like for the processing parameters from 200 to 500 and the processing parameter from 1 to 10. So I have to do some I have to include in this data set some NaN values and the duplicate, so I can show you how you can remove those things. So for that purpose, I introduce some NaN values randomly by using this code like NaN indices NP random dot choice. It means it will going to choose some random values in that column, and then those indexes would be the empty. It means NP dot NaN. Same way we have do for the processing parameter. And if you want to do, you can do also the same thing for the band gap also. Okay. Like just suppose I'm going to do that uh, here. So I have to go for the band gap. So okay. So this is the code NaN underscore indices np dot random choice df dot index. It means it will choose any index, and it will be replaced by false, and for index in NaN indices. So now which index is chosen here, that will be replaced by the np dot n. Same way for the processing parameter too, and same way it is going to be done with the band gap column. Now I'm going to introduce some duplicate rows. Like here in the above code, in the above, I have introduced some NaN values. So if you go for the meta science data, like just suppose you are going to collect the data from the literature. So there are the various literature for the same composition you got. Like just suppose for the strontium titanate, you will get the band gap from a paper, and the processing technique for that paper is different, and you can get the same thing from the any other paper, but the processing parameters for that is different. So in this way, the some duplicate rows is created in the data. So for that purpose, to show that how you can do that. That's why I am introduced some duplicate rows. Duplicates is equal to df dot sample three. So we are going to create some three rows. So df dot pd concat. This command is used just for the merging the data. Like you are getting the data here. Okay, and df and duplicates now. for adding the some outliers. Outliers we have discussed in for the outliers in the previous session also. Outliers is just like your data is confined. Just suppose I confined my data for the processing parameter one from 200 to 500. But in the actual data, you would find any value. There will be some other like high and some low value. So your data is not like bounded in any value or the larger thing. So it would be some other thing like most of the data is between the 200 500, but there is a point which is just about the 10, and there is a point it is like the 7,000. So that is a too high value from this range. So those kind of points are called the outliers because they are not coming in the range of the larger data points. So I have introduced those things also, outlier indices, some random choices. Then those things are implemented here. Okay. So so for all the data, all indices will be the same. So that's why I change the indices for all the thing. Now there is the shuffle the data, like you are going to mix your data. So that's the thing. And so I'm going to run this cell and all the things will be do. So now if you want to see your data, just so as we have already discussed, for that there is a called def dot head. So I have used the some 20 points and some duplicate points. So I have used the 25. So this code will lead to me the show 25 rows. But in the data, there is just 23 rows. Here you can see the material ID, the material name, category, band gap, processing parameters, and the processing parameter 2. And these are the NaN values. It means this data is not there. So if you want to save that data which you have created, so you can save that data by using the command dot to CSV, and then the name of the file which you want to use into the inverted commas, and then index is equal to false because you don't want to save the index of the columns or rows here. So now run this. So now you can see the data. So as you have saved your data now, by default I have that data, but just suppose you don't have your data in the to this memory. So for that purpose, you have to load your data, and for the loading the data, there is a command in the pandas that is the read underscore CSV for the CSV file. And if you have the data in the Excel sheet, then there is a code read underscore Excel, and the path of the data here. So this is the for the to see the few rows. By default, the rows into the df.head is the 5. So that's why you are going to see this only 5 rows. Now, just about in the last session, we have also discussed about the general statistics of the data. Like just suppose you want to see the general statistics or your data, then there is a code uh, uh, into the Python, that is the df, which data frame you have to describe, and there is a command describe. By using this, you will get the description or the summary of your data. Sorry. So now you can see the count. What is the number of things here? Like there is just a 23 point in the material ID. But in the band gap, there is a 17 points. It means other things are the NAN values. In the processing parameter, this just 18 values. So there is a 5 NAN values. And the processing parameter 2, there's only just 20 counts. It means that 3 points are empty. So those are things are on NAN value. It means there is a no value. In the same way, you can see the mean of those values. So the mean of the metal ID 10. So you can check the 1 to 23 value and take the mean. That's the same thing. And the band gap, the mean of the band gap, then the mean of the processing parameter 1, the mean of the processing parameter 2, and you can also check the standard deviation of the data. What is the standard deviation? And you can also check the minimum values, and you can also check the 25% percentile of the data. It means the first quartile region. And then there is a 50, which means the mean value. And there is a 75%. It means the third quartile of the data. And then there is a maximum value. Now, just suppose you want to visualize your data, like what is the distribution of your data? As we got some values from here, like what is the mean of the data, what is the standard deviation of the data, what are the minimum value of your data, what is the 25% and percentile of your data, what are the 50 percentile or the mean of your data, and what is the 75 percentile of your data? Sorry, 50% it is your mean, not the sorry, it is the median, not the mean. Sorry. And what is your 75 percentile of your data, and what is the maximum value of your data? So, but now just suppose that you want to visualize that. So for that purpose, first of all, you have to load those libraries which can be helpful for the plotting of the data. So for that, there is a two libraries. First of one is the matplot library, and the second one is the cban. So these are the some advanced libraries which can you used for the plotting of the data. In not just for the machine learning, you can also plot those. You can use these libraries for the plotting your data. So you can go for the here. You can see here there are the different kind of plotting you can use, and these are the some example, and these are some cheat sheet like some basic coding. Like how you can initialize that, like these are some of the data and now you have to plot those. So these are the some codes. Same as you can also use the cban, which is also one of the advanced library for the data plotting. So we have to take the check the distribution of the data. So for the distribution, we have to check the like how the data is spread all over the values. So for that purpose, we are going to choose some bar graph for that distribution. So for the band gap, for the processing parameter 1, processing parameter 2, first of all, plot plt dot figure fixed size 8 and 6. It means the 8 is width and the 6 is the height. This is showing the ratio of that image. And now SNS. SNS is for the cban dot histogram plot. That's called for that is his plot. TF band gap means 8. It means it will create the 8 parts of the all the range. Now there is a KDE true. So then the plot title would be the plot dot title, the band gap. So we are going to use this like a distribution, band gap distribution. What would be the X label? What would be the Y label? And the plot dot show, plot PLT dot show is used for the see the plot. Same as we have done for the distribution of the processing parameters one, and same for the processing parameter 2. So I have changed the title of the image. So here you can see these histogram plots have the 1, 2, 3, 4, 5, 6, 7, 8. 8 divide all the range into the 8 part. And this is the distribution of the processing parameter 2. This is the distribution of the processing parameter 1. And this is the distribution of the band gap. So these are some basic plot and you can check about the how your data look like what is the distribution of your data, like if you talk about the like the which algorithm would be best for your model, that is depend on the how your data look like. So for that purpose you can check your data, like your data has a normal distribution or the Gaussian distribution, or it has some random distribution. For that purpose, you see, first of all, see your data and according to that, choose your algorithm. So this is the data. Now, here you can see all the data is lying here and some of the point are lying here. Same as all the points are lying here and there is some 3 point which is far away from this point. Same as here you can see all the data points is here, but some of the points are here. So let's check other thing. First of all, these are just a visualization of data. Now we just see how many missing data are there. For that purpose, there is a code df.isNull. IsNull means it will find out what are the NaN values there. Dot sum is used like I'm going want to see the sum of the NaN values in a particular column, like how many NaN values in the column. So for that purpose, I have to run that code, and here you can see the in the band gap there is a 6 NaN values. In the processing parameter there is a 5 NaN values. In the processing parameter there is a 3 NaN values. So how you can handle those NaN values? Like suppose you have a large data, and you want to see there are the various NaN values. So there are the various things by use those by using those techniques you can remove your NaN values. Just suppose you have some NaN values in any particular column, and you can see like this value can be replaced by the mean of the data. You can also think about these NaN values, like I can replace those with the mode of the data. Like suppose there is some default values for any kind of thing. So that is not reported there. So I can use the mode of the data. And in some kind of thing, you can also use the median of the data. That the thing you have to think like what things can be replaced that NaN value. Otherwise, there is a one thing like if there is a NaN values in a particular row, I'm going to remove that row. That's also one thing. So there would be the two things. First of all, you can fill that NaN values by using any statistical technique, by using any algorithm. That's your choice, depend on that. Then there is a thing you can remove all the rows which have the some NaN values. It means if there is some missing value in a row, I'm going to drop that row. So I'm not going to use that data for my model. So what is the we have to do in the handling of missing data? NaN means not a number. Values can enter fair with the data analysis and the modeling. It is important to handle them appropriately by either filling or by dropping them. So there are the common strategies like first of all filling the constant values. That is a good like you are going to fill that by any constant value. Just suppose you are have a data in which there is a something 0 and 1. By default, you know the things is 0, but there is a missing value into the data. So you are going to fill that with the default value, which is 0 or anything else which can be. Then there is a filling with the mean, median, or you can also fill with the mode also. Or there is some strategy which is people used by using the KNN model. So that is also used for the fill the data. Now there is a another thing, which is the final thing. If your data is not lie in the thing which key which in which you can fill the values by using any statistical technique. In that purpose, drop that row. So you are going to drop that row or the column which have the NaN value. So I'm going to show you how you can remove the fill with the mean and how you can remove it by using the median values, or you can drop this that things. So DF processing parameter dot fill NA. It means NA values will be filled with DF processing parameter dot mean. This value will going to be filled with the mean of that column. So if you want to see those values are filled or not, for df dot head. Sorry, I'm going to use the 25 so I can see all the data. So I have filled this, and if you see the previous data, uh, second row for the second cell, sorry, second row into the processing parameter column is NaN values, and that is filled with the mean. So what is the mean of the data? In the summary, we have calculated that 295. So let's see, is it filled with that? Here you can see the second row of the processing parameter 1 is filled with the mean value, which is the 2295.55. Same way, these are also the maybe the some NaN values which is filled with the mean value. This is also the thing, and this also this is also same way. You can also fill it with the median value. So now these values are filled. So like suppose the processing parameter 2 has a something which can be filled with the median. So for that purpose, TF inverted commas processing parameter 2 dot fill NA. It means the NaN values of the processing parameter 2 into the data frame DF would be replaced by processing parameter 2's median. So it will be replaced with the median of the processing parameter 2. Let's run this and see what happened. Now df dot head. Now I'm to want to show the 25 rows. So what are the unfilled values here? Second one and the 11th one. And so second one is a 5.9 and the 11th 5.9. So what is this 5.9 value into the summary? Here you can see for the parameter 2, that is the 50 percentile. It means the median of the data. Okay. So that's the thing by which you can do these things. Now there is a some NN values into the band gap. So you can choose different thing to do that. Otherwise, you can also drop that thing. So I'm just suppose the band gap is not the thing which can be do with the mean. So I'm just letting go with the drop thing. So for that purpose, I'm just going to drop that. Okay. Let's first thing which is called the F field. What do this? F field just fill the data with the previous one. Just suppose there is a category, and in the category part, this thing is not filled. So what this code do? It filled this thing with the previous one. Just like if there is a this thing is missed, so it will fill with the this value. So that is for the F field. For the category, as I see, there is a no NN value, but I just run this for the category thing. So now drop the rows with any missing value. Now my complete data is look like after dropping everything. Df dot add. Sorry, I just want to see all the whole data. So now you can see there is a just NN value into the band gap. There is no other NN values. So in all the columns, we have replaced the NN values with the some statistical parameter. Here we have used the mean, and here we have used the median thing. So now I don't want any drop values in any column. So for that purpose, just there is a code df dot drop NA. Drop NA. It means drop NN values where they are placing. Like they are placed here, they are placed here, they are placed here. It will remove all row. It will remove the whole row in which NN values are placed. So just suppose there is a 23 rows. Now I run this. Now see how many rows are left. TF dot shape. So now there is a just 17 rows. Right, maybe 18 because there is a some zero. It starts from the zero. Okay. Now we have removed the NN values. Now, when we discuss about the data cleaning, there would be some duplicate points also. So, what will we do for those things? So, first of all, we have to check the how many duplicates are there. So, let's check that. So, there is a code df dot duplicated for that, and dot sum it means how many values are there which have the duplicate values. So, number of duplicate rows are 2. Now I want to drop that or df dot drop underscore duplicate. And if I want to say like how many things are replaced, so I'm going to check how many rows are which are duplicate after this dropping. So you can see the number of duplicate rows after removing is 0. First of all, there is a shape is a 17 cross 6. Now the shape is uh, df dot shape. Now it is just 15 comma 6. It means 2 rows are dropped. Now, if you see the data, there is a categorical data. These things, the category. So the data have the outside string values. So your any algorithm can't handle these things. So for that purpose, you have to exchange this data in the some manner. So your machine can So generally for that purpose, sorry, 1 minute. Okay. So for that purpose, there is a something called is the one hot encoding, or there are the some other kind of encoder, which encode the categorical data in some numerical value. Just suppose there is a two thing oxide and peroxide. If just suppose there is a three things, how you can do that? So for that purpose, there are the some kind of thing like there is a just two values. So you can change those values into the 0 and 1. That would be good enough. Just suppose there is a something three value. How you can do that? So there would be the some like there are the three columns, and if that phase is present, so that value is one. Otherwise, it will be the 0. If the other one is there, so there that value is one, and other one will be the 0. Uh, so that's the thing how you encode your data. So here I have replaced with the category thing. So there is a thing, one hot encoding. One hot encoding, it means it will create the data into the some category thing. Like you can do it. You can create a two column for this, or you can also create the one column because it is just two value. So one thing is not, then other one will be the surely that would be. So I created this thing. Now see the data. Now there is a just one category created. Category perovskite, false or true. It means 0 and 1. So it means if this is false, it means that means there is a oxide value. Oxide category. So this is the how the one hot encoding work. If there are the three value, it will create the two column. If there is a four value, it will create the three column. So that's the thing. There is a one hot encoding work. Now we have discussed about the outlets. What are the outlets? If you see the your data, just suppose let's see the data again. Df dot describe. So here you see there is a 15 value, it means 16. And there is a no n values because all the values have the same numbers. All the column have the same number of values. And the mean of the data is the here. And this is the standard deviation of the data. This is the minimum value. And this is the 25 percentile. This is the 50 percentile. It means median, and this is the 75 percentile of the data, and this is the maximum value. If you see the maximum value, is a very far away from the 70 uh, from the third quartile of the data, means 75 percentile of the data. And if you see here, the minimum values are far away from the 25 percentile of the data. Same as here, you can also see the maximum is the very far away from the 75 percentile data. And one thing you can also see the mean value and the 50 percentile median value have a lots of change difference in the data. Here you can also see this is the mean and this is the median. And here also you can see this is the median 2.55 and this is the mean. So these values are the far away. So there is a something wrong in the data. When I see the distribution plot of the data, so in the previous version, this is the actual data, and after removing the duplicate and NaN values, let's see how your data look like now. Now these your data look like most of the data is lie here from the band gap, and there are some points which are very far away from the most of the data. Here same thing happen, and here is the same thing. So let's check the distribution plot of the data in terms of uh, quartile thing. The 5 point distribution which is called. So we have run this. This is the box plot of the data, and we have done that for the band gap, and we see the first quartile of the data. Sorry, this is the 75 percentile of the, sorry, 25 percentile of the data. This is the median of the data, and this is the 25 percentile of the data. And the same you can also see for the parameter one and for the processing parameter two. So there are the one point which is the very far away from this box plot. Same thing here. These 3 points are very far away, and here you can see this kind of data points are called outliers because these falls away from the distribution plot. Most of the data is lie here, but these points are very far. Same thing here, and you can also see in this distribution plot, these points are most of the data is lied here, but these points are very far away. Same thing here, same thing here. So for that purpose, there are the various things. By using those things, you can remove the outliers. So let's just suppose you can remove the IQR outliers by using different technique, by using the manual. Just suppose you see the data like I want to remove this data. I just want to the data which is like from 0 to 10.5 or the 12.5, 15. You can choose your range. Same way, I just don't want to take the data which is below from the 200. You can use your lower bound of the data. Same as you can remove the data by using the some IQR, which is depend on the interquartile region, which is this 75% to the 75% to the 50, sorry, 25 percentile. So first of all, I am you going to use the IQR region. Q1 is the DF band gap quantile 0.25. It means the 25 percentile of the band gap data. Then the same thing. IQR is called interquartile region. It means Q3 minus Q1. It means 75 percentile of the data minus 25 percentile of the data. Now, what will be your lower bound? Generally, it is a statistical technique which people generally use. That is your lower bound is equal to the Q1 minus 1.5 into IQR. It means this value 25 percentile minus what is the difference between 25% to the 75 percentile and 1.5 times of that. Okay. So this minus 1.5 times of this value. That's the thing. That is the lower bound. And for the upper bound, this value plus 1.5 times of this value, IKR. Then that is your upper bound. So that's the thing. So by using that, you can remove your outliers. Now, after the outliers removing, you have just left the 12 rows. Now check how your distribution look like now for the band gap. Okay, these values, TF outliers. You can replace with the actual data. Just I'm going to save with the DF. Now see the DF. Here you can see all of the data, all these values. So I data is like look like a little bit good than the previous one. Same thing, you can use your lower bound and the upper bound. So that is just a manual values. And I choose why I choose the upper bound here. So data would be only the greater than 200 for the processing parameter one. Why I choose this? So here you can see the data here. So all the values, generally all the values are greater than the 200. So you can choose your own value. Just suppose some of your, you can tell me like I want to choose the data which is beyond the 100. So you can take that. So like just suppose I replace with the 100. Same thing if you see here, processing parameter 2. All the data point is lie in this like 0 to 10. So some of you can tell me like let's take all the values which are below than the 20 or the 17.5 or below to the 15. So let's take that. Like just suppose I will take about the all the values which are below than the 15. So now run this. Now see how your data look like now. So, okay. Sorry, I make a mistake. Okay. Now you can see your data is look like this. Like all the data points are close to the value, matlab same value. Like your distribution is not far away. So if you want to see the uh, to describe your data, so I just suppose now you can see the medium, mean, and the median of the data is close to each other comparative to the previous one. I'm not going to say is very close to each other, but in if we talk about the compare it with the previous one before removing the outlier. So now the distribution of your data is now narrow. So so we have till now we have removed the outliers of the data. We have removed the duplicate point. We have removed the NaN values. So other things also you can see by your eyes, like in the data, which is not have to be there. So first of all, you have to remove that. You have to change those. So there are the some human errors into the data. So you can check the data by analyzing that by using this statistical parameter, or you can check any other thing which have to be there in your data. Like just suppose for any data, like I know, like my data should be like in these values to the these values. Like there, I know the lower bound of the data and know the upper bound of the data. If I found any data which is not lying in that range, so I can remove that, or I can check that manually, or I can replace that the actual value which have to be there. So you can do that. So now let's moving ahead. So till now we have done with the how to clean the data. Now again after this we have to look for the how to process the data. How to process the data means like after cleaning the data you are going for the modeling, for the model selection, like which model have to be run, and which model going to be give the good accuracy. But or like just suppose so there is a thing which is called the feature engineering. What is the feature engineering? Feature engineering is a just a thing like which parameters are going to be define my output property. Like just suppose I have the data. I prepared this data. Okay, and these have these NaN values also. Finally, I have removed those, so I can get those values also. But just suppose this is my output property. I want to predict the band gap of my material, and the material names are this kind of thing like strontium titanate oxide, sodium niobium oxide. So these are the thing, and I want to predict the band gap of my material. So I want to train a model which will give me the band gap of any composition. I will going to give that. So what should I have to do? So can machine learning understand the relation between the material name, between the composition of the material and the band gap? If I give the machine to the SNO2, what will the machine learn? S is a letter, it's a capital S, N is the small N, O, the capital O, and the two. How the your machine get the useful information from that? So machine can't do that on itself. So I can what I can do, I can import any library which can decode, which can understand these elements, and that convert these elements into the some useful information, so your machine can detect the relation between the elemental properties of the composition with the output property. Okay, or other thing you can give, you can convert your composition into the some useful information which can be understood by your machine learning model. So you have to choose those features. So just suppose there is a material name. Okay, I have the materials SNO2, Na, NbO. So if I talk about the barium titanate, how the barium titanate involved? Barium, there is a barium, there is a titanium, and there is a oxygen, three oxygen. So how can I decode? So I can check the elemental properties of these materials, these elements. So I can go with the like what is the atomic radius of the barium, what is the radii of the titanium, what is the radius of the oxygen, and I can take that. And I will also go for the like what is the ionization energy, as I want to go for the band gap. What the band gap will be that largely depend on the electronic properties of the material. So I have to look for the electronic properties of the elements. So I have to go for the like what is the electron affinity, what is the ionization energy, what is the electron affinity. I can check that. What is the number of electrons are there in the structure? What is the this kind of thing. Okay. So like what is the radii of the like that will define the what is the size of that element. So we have to go for that. We can go for that. Then that will convert, that will give me to the relation between the band gap and those properties. So you can do that manually, or you can use that by using your library. Okay. So as I show the some paper in the previous where we discuss a paper data in which they convert to the average property and with the standard deviation of the property. So here I have choose some random values which I have taken as a input. So now just suppose these two columns don't have any meaning full for the data, as this is the composition name and this is just a material ID number of. So I have removed those, and that can be removed by using the command df.drop. So now how my data frame look like this. Okay. Now if I want to see this the correlation between this band gap and this input property, which is the like what is the category of the perovskite, is a oxide, it is a or it is oxide. So for that purpose, I first of all I have to create a correlation matrix which is done with the code dot CORR. DF dot CORR, it means correlation factor for the DF. So it will create a matrix. Then I'm going to plot that correlation matrix here. Okay. Now the correlation heat map, and these the my parameters, and this is the parameter. So here you can see this heat map, how the input and output properties are correlated to each other. So this is the demo data, and here we can see there is a no correlation with anything. It's a very few, very small value. Same thing, add some additional parameter. Like if I talk about the real data, so I have to check the what is the input property, like what is the average band gap, sorry, average elemental properties. So for that purpose, I have to do some work into the Excel sheet, or I can do some calculation in the Python itself. So I just randomly use these values. So I created a data set. I just add some rows here. So now there is some input properties. Okay. Now just suppose let's get the all the heat map for all the these values. So this is the heat map with all the things. It give you the correlation factor between all the values in input and output. So now check the summary again. What is the you can use the print df describe, otherwise there is a no need for that. If you are working into the notebook, if you are working into the Python, then you have to do that. So so now you can check these things. Now you can also see the how many columns are there. So here's the thing you can do with the data uh, by the feature engineering, and we will discuss more thing about the how the feature engineering work. So let's take a break of just 5 to 10 minutes. Then we will discuss again how you get the normalization of your data, how you can do more feature engineering into the data, why the normalization and standardization is necessary. Okay. Uh, let's start again. Till now, we have discussed about the how you can clean your data by using removing the outliers, by using the NN values, and how you can deal with those NN values. And besides that, how you can deal with the duplicate values. Now, let's start into the let's going into the next part. Like just suppose I'm just supposing that our data has a complete data set. We have all the features here, and we have all the things which will be the needed to for our model. So now let's start. I have these features as a input parameter, like this processing parameter one, processing parameter two, and this average radius, average ionization energy, and electron affinity as a input parameter. And our target value is band gap value for the composition. So now they have talk about the in the previous sessions also. When we have a data and we want to train an ML model for from that data. So for that, first of all, we have to split our data into the two part, train and test. Test data is going to be used for the testing of our model, like for the evaluation of our model, and our the training data is used for the training the model. Like just suppose I have split it my data into the two part. First is going to be used for the training of the data, and second one will be going to be used as a testing our data. So this is the thing, and generally people have worked with the 70% for training, 30% of testing, or 80% of training, and 20% for testing, and 90% of training, and 10% for testing. You can choose this value according to that. Uh, so there is a no hard and core rule. You have to use any particular value, but generally people have used these values, and mostly people are used the 80% for testing training and 20% for testing. So first of all, I have to decide my X and Y. It means what are the input properties and what are the output properties. So I have a X is equal to df dot drop columns band gap is drop, because these are the just these have to be just input properties. So here is just band gap, which is output property. Otherwise, all the parameters are the input property, because I have left all the other things before, like band composition and the ID of matrix ID. And y is equal to df band gap, which is our target value. So I have done this. So now if I want to see my x dot hair, it will show you all the things. So these are the just text. There is a no band gap. Same way you can see your y value also. Now, uh, if I want to split my data, for the splitting the data, there is a x train, x test, y train, y test is equal to train underscore test underscore split. And in parentheses, there is a first of all, you have to write your x, then you have to write y, then test size, what you want to be test size. Like if you want to choose the 20%, then you have to take this value as a 0.2. If you want to take the 10%, then this value would be the 0.1. This shows the ratio to the world data, test data to the world data. And this is the random state. This is a number which decide from where this data is going to be split. So if you want to the consistent train test split, so you have to fix this value. Otherwise, if you don't fix this value and you run your code after closing this notebook, this random test splitting will be from the any other value. So that will vary your performance of the model, because the training data is changed and testing data is also changed. So for the consistent train test splitting, please choose a particular value. I have split is the for the splitting, and if I want to check the shape of the X test and Y test, so this is for that. So now there is a 9.9 rows for the training and the 6.3 for the test. Now there is a thing which is called the standardization and the normalization of the data set. What is this thing and why this thing is important? As a if you see your data again, if I talk about the just DEF dot describe. Okay. You can see there is a 10 point in your data. The mean of the data is these values, and this is a standard deviation of your data. If you see the standard deviation of the data is a very like some of the values, some of the column it is a very low, and some of the column is a very high. And the minimum of these band gap is the 1.54, and highest maximum for this the 3.4. So the range is 1.5 to 3.44. If I see the range of this 115 to 489, range for sorry 100 to 489, range for these 132, sorry 1.3 to 15, and for this it is just only 1.17 to 0.49. So all the columns have the different range. So and the different order also. So this it is a talk about the hundreds. It is just only talk about the point 4. And if I talk about this is just a 129.5 to 2. So all the things have the different range and the different order of magnitude. So when the model is training on this kind of different values, so our model can feel a uh, problem in uh, to get a point where it will going to show the highest accuracy. So for that purpose, to normalize our data, like I have to change all the ranges like to the same value. Like for the all the columns, the range are going to be same. Or for if I talk about the normalization, sorry, standardization, there it will going to set a data as like the mean of the data would be the 0, and the standard deviation of the data would be the 1. So these are the some things how the standardization and the normalization is used, and why this is used. This is used for the things where to get the higher accuracy of the data in a limited time. So what do the standardization? Send us the data to have a mean of the 0. It will lead to the mean value of the data is 0, and standard deviation of the data is 1. This is useful for the algorithm assume the data is normally distributed. As I told, you get the information about your data if you see the how your data is distributed. So there are the various algorithms which are used for the data where the data is Gaussianly distributed or normally distributed. If I talk about the normalization, what is the normalization? Normalization is just a thing which is used to normalize your data, like for the fixed value to fixed value. In the previous session, we have discussed about the one example in which the data is normalized between zero point 0.2 to zero point 0.8. So zero point 0.2 is converted as a minimum value, and zero point 0.8 is converted to as the maximum value for all the column. So that's the thing. Generally, people do 0 and 1, 0 for the minimum value and 1 for the highest value, maximum value. So this is the minimum value, sorry, maximum value for this. This is the minimum value. So these are the formulas by using what things these things have done. So this for the standardization formula, Z is equal to X minus mu over sigma. Sigma is the standard deviation, mu is the mean of the data, and X is the that value of the original value of the data. And this is the formula for the normalization. This is the Z is equal to X minus, sorry, this one, X minus A over B minus A. X is the original value, A is the minimum value, and B is the maximum value which we want to use that. If you choose any value which is below, sorry, which is not zero, so for that purpose you have to add the A. You have to add the A for that purpose. It means if you take about the minimum value is 0.2, then 0.2 plus X minus A over B minus A. If A is equal to 0, then there is a thing like it will be the 0. So there is a no point for that. So how you can use that? Standardization is generally done with the word which is called the standard scalar. And the normalization is done with the min-max scalar. Min-max scalar, it means I will give it to the minimum value and I will give it to the maximum value, and it will convert my data into the, it will in the normalized form. So let's talk about the first standardization. First of all, you have to load that scalar is equal to standard scalar. Then X train standardized scalar. This is dot fit underscore transform. It means it is going to be fit and also going to be transformed from the values of the X train. Then X standardized, X test standardized scalar dot transform. It is fit on the X train, and now it is just only transform for the test set, because I'm not going to change all the values. So now run this. Now let's see how the X train previously looked like. Now your X train is like standard deviation is 126 for the processing parameter 1, and the processing parameter is the 2.82, and the average radius and this is the mean of the data. Now after the standardization, what will happen? X train standardized. First of all, I have to convert these values into the the data frame, because here one thing which is happened when we run the standard scalar, it convert all the data into the array form. So first of all, I have to convert this into the data frame. Then I have to see the disk summary of the data. Now run this. Now you can see the mean of the data is minus 16 e to the power minus 1 to the power minus, it is just about 0. And if you talk about the standard deviation, it is close, it is very close to the 1. This is the thing which is generally used in the norm into the standard scalar. It convert mean of the data to the 1 and the standard deviation of the data with the 0. Here you can also see now see it's the mean value is 1 and standard deviation of for this is, sorry, mean value of this data is 0 and the standard deviation of for this is sorry, standard deviation for this data is 1. Okay, same as if you see how the it look like before this. standardization process. Uh, so this data is look like, and now it converted into this. So the mean changed to the 0 and standard deviation changed to the 1. So this is for the standardization. Now, if we talk about the normalization, it is done with the min-max scaler. So normalizer is equal to min-max scaler, and the x-train normalizer is equal to normalizer dot fit underscore transform. It is going to be fit as well as the transformation of the data on which x-train. Then x-train normalized is transformed by the trained fit normalizer. So this is the thing, and we have to check the first 5 rows before that and after that. So if you want to see the data, how it look like. So here you can see the mean is the 0.48, and the maximum value is 1 and the minimum value is 0. So your data is converted to like this, like minimum value of the data is going to be 0 and the maximum value is like about 1. You can convert you can choose any other value also into this. So sorry. To use the let's we have see this standard min-max scalar by using the by default values, which is about a 0 for the minimum and 1 for the maximum value. If you want to personalize your minimum and maximum value, then how you can use that? So for that purpose, sorry. Okay, please go. For that purpose, you have to use here min max scalar feature underscore value is equal to, and in bracket you have to put minimum value and maximum value. Okay. So if you use this feature value is equal to 0 point and 0 0.8, you can choose anything. Like if you take -1 to +1, 0 to 1, 0 to 1 is the by default value. So if you are not going to use any value, it will going to with the 0 and 1. So now see how it will be do. Sorry, feature range. Okay, now it. So let's check. Mouse dot desk. Okay, we have to convert the data frame into the. So now you can see the minimum value is 0.2 and maximum value is the 0.8. So this is the thing in the last paper they have done. So same as you can choose different values like -1 to +1, as most of the people use that -1 to +1. So this is the minimum value and this is the maximum value. So this is the way how you can use the min-max scalar and the standard scalar. Where you have to use that, where you have in the when you are going to use any ML model where the normalization of the data is sorry the data of the distribution of the data is a normal distribution. In the those kind of data you have must it is must to use the min max standard scalar, because it will going to you give you to the like zero mean value and the standard deviation is equal to 1. So if I talk about the like in the model we have the gradient descent is used to minimize the loss. So in those kind of function, it is a necessity to use the min-max scalar or the normalization of the data. But there are some models in which it is not necessary. As if I talk about some tree-based model, in which it is not using the gradient thing. So in those kind of model, it is not necessary to use these standard scalar or the min-max scalar. So you can use the data which have the various ranges. But it is a good to use this thing for ML models, because it will lead to the low computation time for the ML. Why? And there is a thing. Why you avoid these things? Avoid standardization when using the tree-based algorithm, as they are invariant in to the feature scaling, because these model don't use the. And there is a one thing, normalization is avoided when there are the outliers. Why? If you see the minimum value is very far away from the data, so your data is skewed. Like it will convert into the min-max scalar. So minimum value is going to be as a used as a minimum value. So your data all the shifted towards the one part. So first of all, please remove the outlier. Then you can use these standard scalar techniques by like standardization or the min-max scalar, whichever you want to use. So maybe it would be good if I'm not start anything else from today. From the next session, I will talk about the like how you what are the different feature selection things. Like we have discussed many kind of thing previously. Uh, like what are the other methods to choose the features. So let's discuss. For the feature selection, there are generally three methods which people are used. First method is a filter method. Filter method, how you choose a filter method. Like just suppose you have a set of all features. Okay, you have a large number of features. Okay, then you select some best subset. How you choose that best subset? So there are the different things you can do. As earlier we have discussed, like the Pearson correlation matrix. So you can choose the best subset from there. I'm going to choose these values, and these are going to be give me the best result. First of all thing, and there is another thing which is called the ANOVA, uh, analysis of variance. So that is also the thing where by which you have choose the best feature value. Then there is another thing which is called the chi-square value. So this is also one thing by which you can choose the different feature, the best feature which are going to. So first of all, you have to calculate the chi-square value for all the models for the input features. Same as you can calculate the Pearson correlation factor for all the features, and you can also check the ANOVA variance coefficient for all the features, and then you can select subset which have the higher values. As in the previous uh, class, we have discussed about that, like they choose a threshold variance coefficient, and all the all the values which have the lower covariance, those are removed, and they are not used for the model. So this is the thing. So first of all, we are filter all the features by any threshold value, and then choose all the features which have passed our criteria, and then those features are used for the model training, and those are evaluation. Those models are evaluated, and is the kind of method is called filter method. Then there is a method which is called the wrapper method. What is a wrapper method? Actually, in this method, it is a just kind of a little bit complex method. What in this method people algorithm do? Initially, it select the zero features. Okay, and it is called the forward selection. Like it is started from the zero feature, and then it select if feature from the data, and then it select the another feature, and it check which feature increase the accuracy of the model, and that's the way it's selecting the feature which feature giving the to the model to the good accuracy, and it removed all the feature which are not giving to the not increase the 1 minute. Sorry. Okay. Okay, so this is the forward selection. It increase the feature number wise, and it select which feature is give me to the increase the accuracy, and it is not going to increase the accuracy. If it increase the accuracy, it will select those feature, and those feature which are not going to increase the accuracy or decrease the accuracy, those are removed. These are not selected into the subset. Then there is a feature selection. Now these are the best performance. Like I included all the features which are going to give me the good result. Now, if any feature is not going to play crucial role, then it was going removed. That is called the backward elimination. It checked all the, like just suppose it select 5 features. Okay. As into the forward selection, I choose the 5 feature A, B, C, D, and E. Okay. Now in the first one, I remove E. and check the accuracy with ABCD features, and check the accuracy with ABCDE. If there is a no significant improvement in the accuracy with E, so I will eliminate the E. Same, all the same things will be happen for all the features also. So there is a way. First, there is a forward selection. There is a backward elimination. In as these things is running and running, so it will lead to the A subset, which is highly influence the output feature, and we get the high performance features. So that's the way. That's called the wrapper method. And maybe in the previous in the paper which is about the stacking fault energy, in which they use the three things. There is a one thing which is called the wrapper method. Another is the embedded method. In the embedded method, they check a they create a various subset. Like the suppose there is a five feature, it will create a it by using the permutation combination, it create a subsets, and all the subset from all the subsets, the model is worked. If it is performed well, that is selected. Otherwise, it got eliminated. So it will work on the all the subsets, and it will give you a best set. Okay, among all those sets, this is called the embedded method. This is a very complex, these are two methods, wrapper method and the embedded method is a very time consuming. As you can see, there is a, like, just suppose if you have a five features, so there it would be created the five, there would be the 20 data, 20 set. So 20 sets run all the data, and then it will give you which subset give you the highest accuracy. So this is the thing. In the next section, we will talk about this method, how you can run on your data set. For now, is enough. If you have any question, please ask me. Are you have any question? Okay, then thank you. Let's meet into the next session, which will be held on the next Saturday from 6 to 8 p.m. Thank you so much. Good night.